All right, now this question took me a little bit to figure out, mainly because I hit like a mental brick wall, but it is, um, it is a little bit complex because you've got to really think about this one, and um, it's similar in the way that probability expects you to deal with numbers and compute numbers in your head. This one expects you to think about this box in a three-dimensional space, and when it comes to part B, it expects you to think about the graph in your head. Um, the part I've got to run through. So I'm just going to run through the question real quick. It gives you a box that's 30 by 80, and it's got these corners cut out there, x by x, and they're the same, but we just don't know what they are. And don't be fooled by um, how big or small those shapes are. Really, these can be as big as they want to be. Um, so this is, you've got to think about this in a three-dimensional space. If we fold those two sides up and those two sides up, what is the volume of that box going to be? That's part A. Part B, what we are actually finding is we've got to differentiate this once and twice. It's basically finding our stationary points, and we actually want to find the maximum. This gets a little bit confusing because you're actually finding the maximum x value, what x could be, to create the maximum volume in that box. And that is a graph that you're kind of thinking about in your head. It will give a negative value in terms of the second derivative, but that just tells you it's concave down, and that gives you the max, and that's a little bit confusing. And then finally, once we've found our number, we just crunch it into back into our equation. So C is actually quite straightforward. A is a little hard, B is very hard, C is really easy. But I'm going to try and go through and explain it. This is question 9 in your textbook. The first part is, okay, if we're trying to find the volume, and this is our box, well, we know if we're going to fold these up and those up, the height of the actual box will be x. Okay, we know that. I'm just going to do dots to symbolize times. I know the length is going to be 80 minus 2x. And I know my width is going to be 30 minus 2x. Now, if I just times these should crunch out to be giving me my answer. What I'm going to do is go leave the x here for now and just go do these, expand them, and then I'll just times everything by my x. Okay, so I'm just going to go 80 x. 80 times 30, 80 times 30 gives me 240. 80 times 2 give me negative 160x. 30 times 2 is going to give negative 60x. Negative 4 and negative 4 is going to give negative 4 squared. Times that all by x. Actually put these together whilst I'm at it. 160 plus 60 is going to give 220. That looks promising. And also times this by x. So we should, oh, I made a mistake. That should be a plus. We should get 240x minus 220 x squared plus 4x to the power of 3. And that gives us our answer. Okay, that's not that hard. The next bit is we're going to use this to find the stationary points. Then we're going to find out which one is going to be a maximum. Okay, so if we go v dash, that's going to be 240,000 minus 440x plus 12x squared. Okay, If we make v dash equals 0, we can find our stationary points. I'm just going to rearrange this real quick. 12x squared minus 440x plus 240, 0 equals 0. Did I do that right? Yes, I did that right. Now, I'm going to be honest. I had to use a calculator online to solve this. I got to this part here and I got really stuck, and I couldn't quite do it. But just to get the ball rolling, what's that going to be? 2400 divided by 4, 600. You get to this. Here I couldn't quite do it. I had to use a calculator online, and I ended up getting this. 3x minus 20 x minus 30 equals 0. It's like, okay, here, if everything equals 0, you can get rid of that 4. And to make that equal 0, x must equal 30 or 20 over 3. And we're like, okay, so here we got our two x values. We want to find our second derivative. V dash dash is going to be negative 440 plus 24x. And if we put in our values, that will tell us if it's a maximum or min. So when x equals 30, v dash dash equals negative 440 plus 24 times 30. This is where it gets confusing, so hold on to your hats. Whoa, that's a plus. Equals to 80. Okay, now because that is above 0, that is concave up, hence that is a minimum. Okay, even though that looks promising and it's a positive value, that is actually the minimum and not the maximum value that we can have for it. If we're trying to get the minimum amount of volume, we would use x equals 30, okay? But we're not. We're trying to find the maximum volume. We're trying to increase our load. So, our x equals 20 over 3. V dash dash is going to equal minus 440 plus 24 times 20 over 30. Oh, 3, sorry. Well, I cancel that. Plus 24 times 20. Okay, that gives us this, which is concave down, which therefore is a max. Okay, so therefore the maximum that we can have at these stationary points is going to be 20 over 3. That's what it's going to be. Okay, so the maximum that we can have for x is 20 over 3. Now I'm actually going to just change that very quickly. 20 over 3 shift SD is 6 2/3. 6 2/3 centimeters. I'm going to say is, sorry, pull that up for you. The max, hang on, will generate, we'll say that, will generate the maximum possible volume. Because that's what we're after, aren't we? Yep. Okay, that's the hard part, and it just took me a while to get it. I got held up on this part and understanding the positive and negative values, but if you just think about it, what we've done previously, it makes sense. Like, if this is a positive value, that would be a minimum. It's going to be concave up. If this is going to be negative, it's going to be concave down, but that will be the maximum. Okay, we got to look at the nature of those things. Okay, it gets a little bit confusing jumping from there to here, but these numbers tell us something about these numbers. Okay, the last little bit I'm not going to really bother doing. You just get this number and you just jam it into your original function, and it will generate the maximum volume.